My name is Shannon McManus, and I am the Director of Professional Learning at the Museum of Science in Boston for the Youth Engineering Solutions curriculum. And I just wanted to welcome everyone here to our webinar for the evening, our Engineering for Every Learner. So we're going to be talking about strategies for students with support needs. And again, as you're joining us, feel free to type hello into the chat and share where you're joining us from. But I'll get started before I introduce my two guests tonight. So we're hoping for this webinar, by the end of this session, you will all, our participants will explore how hands-on engineering can support and engage students with support needs. And we'll identify some of the features of the YES curriculum and adaptations that can increase access for all learners. So just our plan for tonight, or our little agenda, is I'll give you a very quick overview of the Youth Engineering Solutions curriculum. I'll share our guests that I have here tonight, and you'll hear from those guests, from our experts, and then we'll have some time for questions and answers at the end. So my brief overview, if you're joining from and aren't familiar with Youth Engineering Solutions, I have just a very brief overview of what our curricular resources are about. So our mission at the Youth Engineering Solutions is to create really the next generation of problem solvers through hands-on STEM learning. So we're based out of the Museum of Science in Boston. So hello to my New England folks who have already introduced themselves. And we really just hope to empower young learners through accessible and standards-aligned STEM, engineering, and computer science curricula for pre-K to 8th grade learners. We are formally known as Engineering is Elementary, so you may have heard of EIE, but we're really backed by 3 decades of research and leadership in STEM education. And we're hoping to share some of that work with you tonight. So we have resources for all types of settings and age ranges. So whether or not you work with our youngest learners in preschool, we have our We Engineering curriculum, elementary school, middle school. If you're looking for out-of-school time resources, that would be our enrichment resources. We even have resources for families and caregivers. Lots of things, lots of resources ready to use. You can just go to our website at yes.mos.org, find free for download curricula, teaching slides, and lots of resources to support you as you implement hands-on engineering and computer science. And really, we have these design principles that really anchor how we develop our curriculum and create our curriculum. So we really just want students to engage in actual engineering and ways of doing engineering. So like real authentic practices of engineering, which include designing and building, testing, collaborating, and persevering through failure. So we hope that those kinds of ways of thinking and doing really helps to build problem-solving habits, collaboration, and persistence. And we've also seen that it also really helps students to see themselves as engineers and just kind of deepens their own STEM identity through these meaningful activities. And so we do that by creating meaningful activities for students to engage with. So they address real-world authentic problems. So we have a unit that has them tackle plastic pollution and design filters to reduce the amount of plastic that flows into a bay, or they focus on declining bee populations by designing a hand pollinator, or keeping medicine coolers cool. So we intentionally design activities so that students must think and behave like real engineers. And so these are, you don't need to read all of these, but I just wanted to reference them because these are these kind of intentional ways we want students to be thinking and behaving like engineers. They'll be exploring materials, they'll be balancing trade-offs, they'll be collaborating, and as I mentioned, persisting through failure. So these are just every lesson and every activity we create always has these ways of thinking kind of at the core of what we're trying to get students to do when they're engaging in these these authentic problems. Um, and really, all of these resources are grounded in this engineering design process. So you'll see our guests tonight talk a little bit about this design process. Um, but really, we this engineering design process guides learners to ask questions, to imagine solutions, to build and test ideas and improve their designs through iteration. And we have lots of scaffolding materials that support students through those different steps of the engineering design process. So that is my very short overview of youth engineering solutions. But tonight, my guests, I'm really honored to have two amazing educators join me this evening to really bring some of these resources to life by sharing how they've used them with students with support needs. And so these two educators come from different settings. So Dr. Bree Jimenez is a professor of special education and the chair of Department of Educational Psychology at Baylor University. And Kaitlin Cunningham is a grade 3 through 5 math special education teacher in DC Public Schools. But what's bringing us all together and bringing these two amazing educators together is Youth Engineering Solutions and really its ability to create access and opportunity for students with disabilities to engage in projects that they may not otherwise experience. So with that, I will pass it over to Dr. Bree Jimenez to introduce yourself. And do you mind? I can click through the slides for you. Does that work?
That's fine.
Okay,
Yeah,
great.
great. Hello, everyone. Again, my name is Bree, and I'm at Baylor University and have been engaging with students with disabilities, including students with intellectual disabilities and autism, multiple disabilities, lots of different kiddos and their teachers, and really finding the YES curriculum a really great way to kind of come into that from the perspective of really thinking about access to make sure that all students have the ability to engage in engineering. And so the group is kind of those that sometimes are called extensive support needs. But I think what you'll see, regardless of the kids that you might work with or engage with, is that a lot of the strategies and some of the things that we've done or the ways that we've used the YES curriculum could really be beneficial to a lot of students for various different reasons. Um, oh,
Yeah, let me
okay.
stop sharing and reshare so that folks can see the slides clearly. Thank you
Yeah.
for sharing that. Let me reshare. Um, Give me one moment.
So while she's working on that, we just kind of to give you a little bit of background of some of the things that I'm going to share is that we've what I've done is we have a NSF funded grant that is using the EI or the Yes, curriculum. And it's been kind of neat to be able to engage in this and have an opportunity to also simultaneously look at the research to support the teachers. So a lot of the things that I'm showing you are coming from research projects that we've had success, whether it's teacher success of helping our teachers figure out how to really bring this to their classrooms and or student success of students engaging more or students communicating more or students sometimes it's science outcomes of really getting like the science content, but we've stayed really focused to the engineering behaviors that we're looking at. So we can go to the next slide. So I think the biggest thing that has really been important for me and I think aligns really well to yes is that this is engineering, but it's engineering from the perspective of what is engineering. Not only this idea of math or science sometimes that we see in STEM. And so the inquiry and the problem solving and the critical thinking, the communication, the self-determination of really having kids identify that I can solve problems. I can make things. I can, you know, I identify as an engineer. You know, that's a really big thing. And I think that that comes out very clear. And so I think this is an important piece for all students, but I'm going to kind of, be biased myself, which is this is super important for students with disabilities, where so much of the things that sometimes, or diverse learners, sometimes it is that piece that is challenging. And so this actually gives us a really great opportunity to practice self-determination, practice problem solving, practice critical thinking, practice making informed decisions, and all those things in the context of engineering, which is really important, not just to do it kind of at a different time like we sometimes see in special education with the students that I work at. So, I mean, overall, this is what we're looking for, improving quality of life. That is our overall objective of all of our students. And sometimes in disabilities, I think we do say that. So, um, really like kind of talk about quality of life. Well, what is quality of life? And really, it's these skills that we need to help build and these dispositions, these behaviors that we want to see. And so, I think, the population of students that I'm currently working with are students who have intellectual disabilities and autism, and often haven't been given opportunities to engage in sometimes science and math, to be quite honest, but let alone engineering. And so that's what's been so exciting, is to really think about how important engineering has been to really make sure that we are kind of like squashing those misconceptions that students with more extensive support needs wouldn't benefit or couldn't benefit or shouldn't be, or maybe we're not even asking those questions. And so we are working currently with a local STEM museum here in the Waco area, and using these units to provide opportunities even in the community to start to squash those type of misconceptions, that maybe this group of students hasn't really engaged in true engineering. It was more like art activities that we called STEM, and really getting into what is it that we want. We want them to build their problem solving skills, and what does that look like? So, some of the things that I wanted to kind of share with you guys was, in some of our research, we've done some longitudinal research that's gone over a couple of years of working with the same teachers over and over, and really looking to see what are the things that were either the challenges for them, or what are the things that this really gave them great opportunities, or what are some of the things that through the Yes curriculum that gave them opportunities to engage in other things that sometimes we prioritize or that we think are important, but may not have traditionally been seen as STEM or engineering outcomes. So communication is one of the big ones that has come up, of how important it is to build these communication skills, but then also what are some of the barriers that sometimes the teachers have had to work through. And so they talked about really needing content specific communication tools to help for kids who might have limited vocal verbal behaviors. So sometimes the materials themselves become the communication. They can point to things. They can just grab the pom-pom instead of, circling it or telling you that. Or a lot of the students that I work with use assistive technology devices even to communicate. And so one of the things that they talked about was, some of the teachers, was that there are, I think naturally in our lessons, there are a lot of open-ended questions. We're posing a question. But what about the kids with or without disabilities? So I would argue this is not a thing that's just about students with extensive support needs, but there are lots of kids for lots of different reasons that we ask all these open-ended questions, and then we just sit there. And guess who talks? The one who's the most rambunctious, the one who's the most social, the one who knows the answer all the time, the one who doesn't care if they don't know the answer. They'll just shout out anything. But we might be leaving those other 20 kids in a group just sitting there listening to this kid's answer all the time. But what about also kids who might not know the answer or don't know even where to go to even get that answer? And so we've been working really hard on the communication, and you'll see some of the things in the next couple slides that showcase ways that kids could respond or ways that might support if a student was given this open-ended question and didn't know how to respond. How might a teacher start to shape that and start to give them those scaffolds to get to the answer instead of um, asking the question and really looking for the kid who answers most of the time. And so that was a challenge for them and probably one of the biggest one. The other one was sometimes there were fine motor barriers. Some of our students have very limited ability, and then also the need for visuals, which there are lots of visuals that are already built into the YES curriculum. That's been so helpful. It's just thinking about how you might use them. So, one of the things, will you go back one slide really quick? I'm sorry. Yeah. One of the things is thinking about universal design for learning. And so I'm going to go through the next couple slides super quick so we don't run out of time, but really just wanted to show you this information. And so we did create core boards. We created some different ways, but if you notice up there where it says material, that is not something we created. That's something that comes with the curriculum. And so that's been super helpful because those are often the type of vocabulary and supports that we create in special education classrooms to support kids where it's already there. And so we've been able to use those. Sometimes we cut them into pieces where students can show understanding of which one of these is materials, just so that they understand when I'm talking about materials in their mind, they're thinking about the stuff we use. Because sometimes it's a lot of new stuff, a lot of new vocabulary that's being used in lessons for students who might have very limited communication. Next slide. We've also looked at supporting those open-ended questions. And so these are the questions in the PowerPoints that come with yes. And what we've done is we've just added response options that might go with it. And one of the things we've done with some of our students is the teacher might ask the question and there's no options up there. And then for the students who couldn't generate their own responses, they click the PowerPoint again and then the pictures come up as a kind of a way. Some of our teachers will use this and their students wouldn't be able to verbally answer. They'll come up and touch the picture. There's lots of ways. And if a student doesn't know the answer, the teachers work on like thinking about, okay, so he needed to improve his hand pollinator. Did we need this or this? Or maybe they reduce the options or those kind of things. We also looked at making it really, really clear of what are the behaviors that students engage in when they're asking or when they're imagining or when they're planning or when they're creating. And this is already scripted in the lessons kind of to go through, not scripted, but it's told to go through and like remind them that they're in the imagine phase. But we will also, while they're imagining, while they're drawing, while they're brainstorming, we will be like, oh my gosh, look at you, you're imagining. And we're bringing it right back and we're making it really, really clear throughout the lessons. And then we also look at other times where we're like, that was so cool what you just did. What did you do? Did you create or did you plan? And really having kids start to think about themselves as engineers in the process and what they're doing and when they're doing it, which has been really cool and a lot of self-awareness really from a self-determination standpoint. So we've also looked at repeated storylines. So the stories themselves are they're not long, but for some of our students with more severe disabilities, they're like there's a lot of language for students who sometimes have like a hard time processing a lot of language. And so we've actually added like in this, as she goes through all these things together, Yasmin is afraid of the dark. Oh no. And the kids will say that when they get to each page. And then later it's like, Yasmin is working with her cousin to come up with a solution, and then like it's a little bit more of the story of what she does, and then it's like Yasmin is creating a solution, and then maybe at the end it's like 3 pages where when you read it it says Yasmin's an engineer. So it's the idea of there's a problem, she's trying to solve something, and now she did. So those are the big ideas, and for some students that's really what I need them to get out of the story. Remembering Yasmin and the name of her cousin and how they were making a nightlight and who wanted to sleep on what side of the room and all that was too much. When I really wanted them to understand these big ideas. So it's just some of the work we've done in literacy for this population of students. This is a great strategy for story read alouds that we've added into our STEM stories. I mentioned this before, the response boards, which is helping the students increase their participation, but also their open-ended thinking. And I know the open-ended, like, yeah, but there's choices. For students who are nonverbal, they're going to have something in front of them to choose from. And so rather than just not asking them the question, I would rather put examples and non-examples in front of them and say, what are you thinking about using? And so when they pick the picture of dropping something, that makes no sense. When they pick the picture of a craft stick, let's go get the craft stick right now and show me your connection with your thinking. And then, like, I'm going to look for them to keep using it. Um, This is just another example where we added the picture symbols, and they could have been the things on the response boards, or we could have added them up. This is a teacher using the book with one of the students, and you can see over to the very like bottom of the screen, that's actually an assistive technology device that would have kind of all those picture options on it for him to choose. So not just asking kids to write and color and circle when those might also be barriers for certain kids. So. That's just another example. One of the things that I just wanted to mention is so this has been a big one for our teachers is really to think about what is it that the teacher does when like when they ask. So like independently, I'm asking the student to explore the materials and build. But if they don't know what to do or they're just kind of lost, what is the next thing? Is the teacher going to walk over and hand them one of the materials? No. I want them to come over and maybe gesture towards and say, like, something like gesture towards all the materials to kind of say, you're going to be using this stuff, do something, and then give them a chance. And if they still don't know, let's pick a handle. We need a handle for our pollinator or it's your turn. And if they still don't know what to do, then maybe the teacher go, I think I'm going to use this. Okay, now it's your turn. What would you like to use? Look at all the stuff. And then, you're modeling that behavior. And if they still don't know, then yeah, we're going to go through it together. But really not jumping from that independent all the way to like modeling or all the way to a verbal. And that is very, very common and very common sometimes when you work with students with more extensive support needs, students who maybe are a little bit confused, maybe students who really have never done something like this. And so this is just good rule of thumb for just good teaching, but something that we've really had to spend a lot of time on also working with our teacher assistants and our teachers to make sure that they are really truly giving students an opportunity to engineer. This is just another example, and you can see the like where they would circle their choice of what they wanted to use in their planning because having them draw what they wanted to like just plan what you're going to do was going to go nowhere. So we needed to use picture examples, and those pictures actually came from the curriculum. And I think this one in particular is set up this way in lesson five. Sometimes they weren't, but we then modeled something like this. And so this is the book that the students have below, and it was really helpful for them to refer back to their book when they started to plan, when they started to build, to see if they were even using the things they had planned, which I've been told is very common that students don't. So, um, yeah, just some more pictures of ways our teachers in our studies have used the board. So they put like the bees and they actually had like a bee that was cloned. And then you could move the bees at the bottom to determine if it was less or more on their first or second trial of using their pollinator. And on the bottom one where it says the five and the three, they actually did the activity, but then on the smart board they had the pictures cloned, and they would move the pumpkin over to the ones that had been pollinated, and then they used it as a math lesson to also count how many. But if you can see, there were three bees in the first one, and there were only two bees in the next one. So what she's trying to do is show comparison that when there are less bees, less of the flowers got pollinated. So yeah. This is something else that we've done where we've looked at some of the engineering practices and we've just looked at how they might be worded for students. So I think about problems. So really, our big focus in our project has been that we did not want to focus too much on math outcomes or science outcomes. We wanted to really make sure that we really wanted to make sure that the practices were really, really salient to the teachers so that we were really thinking about how are we building problem solvers and what does that look like for kids who have extensive support needs. And we don't have all the right answers, but over and over we see they're problem solving. They are persisting through failure, but we also wanted to help the kids recognize when they were doing that. It's not an I gotcha. Like it's not like we want them to be problem solvers. We want them to remember that they're supposed to be problem solvers. So we changed the practices and often brought them in as I try and try again to make things better. So that's persisting, but just to make the language a little easier. And it's kind of cool. The kids will sometimes say, like, I tried and tried again. It's really cute when they do that kind of stuff. So they're recognizing their own self as so this is too much to go through, but this comes out of a research study that we did a couple years ago, and we just looked at all the ways in which we what we did for representation, expression, and engagement to really make sure. So, like, think alouds were really helpful. Examples and non-examples were helpful. And a lot of these things are already bedded into the Yes curriculum. And if they weren't, we added them, or what we did was like they're in maybe a lesson, but then we would bring them into the next. And a lot of them you'll see because of the population we're working with, you would never expect any curriculum to cover all of the rare things that students with more severe disabilities would need. But what we're finding is that it's all there. We just can use the resources and a quality engineering and a really great format to be able to make it accessible to all the learners in our groups. And that's it. That just brings you to a couple other documents and articles if you care, but that kind of shows some of this information. There's like a teacher article in there on how to create access for kids with more extensive support needs and plan more universally designed engineering lessons.
Yeah, thank you so much, Bree. Appreciate it. And Bree will be sticking around. So we will take any questions at the end. But now I just wanted to transition to Kaitlin so she can share her experiences as well. Oops.
Awesome. Thank you.
Mhm.
And please, everyone give it up for Bree. That was amazing. I feel like Bree talked on so many strategies that you may hear now it again. But that repeated practice, repeated instruction is something that I know I do for my students. So we're going to do it here as well. But hi everyone. My name is Kaitlin and I work at a Washington, D.C. public elementary school. I'm a math special education teacher for grades 3, 4, and 5 at a school that follows the inclusion model. I case manage about 15 to 18 students' IEPs, and then I provide them with math specialized instruction. Um, if you want to go to the next slide. Oh, just kidding, not yet. Go back. Not yet. Can't give them away just yet. So kind of what my day looks like is, so since we are a inclusion model school, about 60% of my day is spent in the general education setting where I'm supporting not only the gen ed teacher, but I'm supporting my students. And then about 40% of my day is providing that small group instruction within my classroom that aligns to my students' IEP goals. We have a wide range of abilities at my school. To get an idea, it's usually falls within like the four biggest categories that we see. It's either other health impairment, which usually ADHD, specific learning disability, which will be dyslexia, processing challenges, oral or written language challenges, and then autism. So those are the four kind of big buckets that we see at my school to kind of give you guys a idea of the students that I am working with every day. And so that kind of, again, provides an overview, but let's dive into the data and see why YES is so impactful as a curriculum. So actually last school year, 2024 to 2025 was the first year that my co-teachers and I really were consistent in implementing YES curriculum and providing students with engineering opportunities. And the data was amazing. We saw our students with IEPs rose 25% in mathematics on the standardized assessments at the end of the year, which we found out to be the highest growth of any elementary school in DC, which is fantastic. Yes, there's a lot of things to contribute to these gains, but I will say that yes, I believe was a huge part in this because it gave my students so much confidence when having to problem solve. A lot of the standardized assessments, they're standardized. So they're not made for our students. And it's really hard for our students to break down those problems. But I feel with engineering activities, they were able to practice those problem solving skills throughout the entire year. So I was very proud of them. And it's the data's there. Yes is amazing. So if we want to move to the next slide. So let's talk about why YES is so amazing. So as a special education teacher, I believe that it offers access points to all learners. YES activities and curriculum includes built-in supports already there, like Bree had mentioned. That and what I really love about the YES curriculum and the resources that they provide us is the PowerPoints. When you download them, you can manipulate the pictures and the images that are in there. So for example, like that the graph that we're seeing on the screen, those pages, those papers, the tape there, the scissors, the rulers, you can manipulate all of those and copy and paste them and put them on like worksheets, for example. And that's what I usually am doing. So it's so fantastic to have this foundation of great curriculum resources that then I kind of tweak and manipulate and modify to work for my students. And it provides hands-on design process, and it's providing for deeper engagement and memory retention. The research shows that when we give our students opportunities to have experiences and put those experiences in their long-term memory, they're able to remember and hold on to them and retain them moving forward. A lot of teaching that we see is usually short-term memory where it's just memorizing. But if we're giving them these opportunities to put it in their long term, they're able to retain it and hold on to it and be able to apply it in other situations, which is amazing and fantastic. So if we want to move to the next slide. So some ways that I have adapted the YES curriculum to be more accessible for my students is through previewing and pre-teaching any necessary skills before the whole group instruction. That has been a fantastic skill and that's worked for my students and myself. And I'll go over more of that and what that looks like on the next slide. And then supports during lesson, strategic groupings, making sure myself and the gen ed teacher, we work together to figure out, okay, what students are going to work best together, what students are going to push each other, what are the students that we can think, okay, this student's not going to talk as much, how can we, so strategic groupings as always, extra timing, especially within the planning phase. We don't really provide any like time constraints. We let the students build as they need. But if we do have time constraints, we will put a visual timer so that they have that reminder there and they can refer back to it. Modified worksheets to be more accessible, sentence stems for turn and talks, checklists, and then exit tickets that assess IEP goals. And then you can see on the screen, so I've just added in those sentence starters for my students, or the sentence starters or discussion prompts, because a lot of my students need that just starting point of how do I access this conversation. And so with those prompts, they're able to turn and talk and have a conversation that's meaningful. And then if we move to the next slide, I'll talk. Oh, yes. So the challenge or the lesson that we were doing was the students had to create a bench challenge or a bench for, they were given a photo. It was a bunch of people at a bus stop, and they were presented this problem of how can we make this more accessible, or how can we make this bus stop better for these people? And so they were like, oh, what if we created a bench? And so they then have to create a bench using paper, tape, scissors, and rulers. As you can see, the yes already has these images of these pictures on the worksheets. That's already given to you, which is fantastic. And then so I just copied and pasted those materials again that they will be able to have and use when creating their plan. Because I noticed a lot of students, when given the planning sheet, they'd be like, Miss Cunningham, what are we using again? Or what am I going to do this time? And so having just that quick image and the word so they're able to label it, it was really helpful for them. Sorry. And then we have on the solving problems, again, just putting in a quick sentence starters and also a word bank, so that my students were able to write and access that worksheet. And now, thinking about that bench challenge, I thought before we even introduced that to them, I wanted to give my students an opportunity to practice with these materials and practice with these skills, but I still wanted to make the bench challenge accessible to them, but I didn't want to give them the same challenge. So instead, I created, if you go to the next slide, I created a challenge that was kind of similar, the same exact materials. So this gave them an opportunity to work with the same materials that they'll see the next day, um, but in a different kind of scenario. And our cafeteria is a very open space, and it's connected to our PE space. So it's very loud, it's very overstimulating. And a lot of students are always like, can I go to a quiet place? Can I do this? And so, again, this was a relatable problem that they could connect to, where they had to create a model of a table that we can put in a quieter area within that cafeteria space or cafeteria adjacent. Again, so it's giving them a problem that they can relate to, same materials, same kind of build, but we're doing it in a small group. We're doing it as a preview the day before the whole group lesson. I have found a lot of success with this strategy. My students, when I first presented them this challenge, they were like, but why are we making a table? Why can't we just go ask the principal to buy a new table? They were very literal about it. And I was like, okay, we're gonna imagine, we're gonna ask, and taking them through the engineering challenge. And then the next day when we would do it in the whole group, they're like, oh, okay, Miss Cunningham, I see what we're doing. And they felt so confident because they were like, oh, if we move the paper this way, or if we manipulate it and oh, cut really small pieces of tape, they felt like experts. They felt confident to be able to access this curriculum at a equitable level compared to all of their friends. And so like that again is my job, and wanting to make sure that they are able to access this curriculum in the gen ed setting and feel confident and feel successful. So this is a strategy that I really love and I recommend, um, because it's been really successful for my students. And then if we move on, and then so another thing that I've always been doing is doing kind of like an exit ticket. This will be an exit ticket for the whole class. Like everyone in the class will receive it, but one or two problems will be assessing one of or a few of my students' IEP goals. This is to help keep me accountable for always aligning these things to the IEP goals. And it kind of keeps me compliant where if someone comes in and is like, oh, Miss Cunningham, why are you doing these engineering activities? I have that documentation, that proof of like, oh, but this is all aligned to their IEP goals. We make sure that this is setting them up for success to meet their IEP goals, but then also to be a problem solver and to be successful and have um, equal opportunities. And then, so the impact on students. I know I've mentioned this a lot. My students are so happy doing engineering activities. We usually always do it on Fridays. They look forward to it. I come in with big bins and they're always like, yes, it's engineering day. But it's not only my students that are excited about it, but the whole class is. Um, they're able to show their strengths that are not visible in traditional assessments. Peer collaboration builds communication skills and confidence. And students engage deeply when content feels hands-on and real. And then students are able, again, to retain more through experiences. I know I went through that very quickly.
No, this was great. I know we
For a
could.
second, I was like, did I breathe?
I know, and I know you were all stuffed up, so I appreciate that. I appreciate both of you. I feel like
Yeah.
we've just gotten so much information, and so thank you to you both. And so, what we'll do, I have a couple follow-up questions, but how about if right now the way our webinar is set up, folks can raise your hand, and when you raise your hand, I can unmute you, and you can ask questions. So we can certainly open this up to any questions from the audience. And I guess as we get started, maybe I can ask a question to you both and get some of these ideas out there. So I guess having been, I was a general education teacher. I taught high school science and integrated science and physics. So let's just say if I or somebody out there, hasn't really thought about trying STEM with students with special needs, what might be a good first step, or what kind of what would help in this work? What kind of skills should I have? What would be some good first steps for this? And this could be either Bree or Kaitlin. Yeah. Mhm.
I'll jump in. So, no, I don't think you have to have any skills. I definitely did not. I mean, I had the skills of knowing who my students were and what some of the strengths and barriers would be. Um, but I don't think you have to have, like prerequisites as a teacher to do this. Um, I think one of the first steps would be is to try it. I mean, honestly, is to open it up and try it. One of the things that I know for us has been really instrumental is like we wanted to come into this instead of saying like, oh, those kids have special needs, therefore those kids need something different. We didn't want to do that. We really wanted it to be that we came in and we said, you know what? I see value in giving our students an opportunity to engage in engineering. And I see value in me as a teacher trying to use the materials and then use what I know about teaching my kids. Teachers know their kids, they know the things that they need. And so I think maybe the first step would be just to try a lesson, try, lesson one in the unit or try one of the mini, lessons, and try something and then go from there to say, okay, you know what? Like the teacher said, my kids, I asked the question and then they all just stared at me. And so communication. And then they were like, okay, I got to come up with some options for my kids or sentence starters or whatever it is. And so I think that's really to me the biggest thing is try it and then from there be able to pivot and say, okay, there's some more supports that might be needed for my students. And honestly, if kids didn't need the supports, they probably aren't, if there weren't any supports they needed, they probably not students who have some learning difficulties. So, it's that's expected and that's okay. And that's perfectly fine. And so I think it's really trying it.
Nice. Caitlin, do you want to add to that? Like first steps or yeah,
Sure.
I guess. trying it is a good first step, I
Yeah,
think.
absolutely try it.
Yeah.
I think with trying it, when you're downloading the resources, my first instinct is always to go preview the PowerPoint.
Oh.
I always will go through and kind of glance through the PowerPoint just because I myself am a very visual person. And so I'll look through the slides and I'll be like, oh, okay, I can do this. I can try this. And I feel that's always been a great first step for me as well.
I like that. Yeah.
Mhm.
Someone just asked about, we do see a lot of educators implementing in out of school time settings, camps. So it looks like somebody is asking, Michelle's asking about experience or advice in implementing STEM in a camp or out of school time where there's also mixed age groups.
Everything we've done has been mixed age groups because very rarely with kids with more extensive needs do you ever find a third grade classroom. Like it doesn't exist. It's like a K-5 classroom
Mhm.
often.
Mhm.
So everything we have been has been mixed age. I think that when you go through, there are resources in there, and Shannon can probably link you to them better than me, but there are resources in there that kind of tell you what grade levels it links to or what standards sometimes or where. But I think to me, going back to the idea that like um if they are mixed age groups, like maybe having like primary and secondary, maybe separate if that's possible. I think that would get hard. Um, Maybe I'm not answering your question, but I'm not sure that it doesn't, I think the focus is on the engineering. And so, especially from an out of school standpoint, if you are doing the bee pollinators in a primary group, that's fine. And you could even think about like how kids work together and maybe making it opportunities for older kids to work with younger kids. Just and maybe set some ground rules of, like make sure that, the older kids don't just take over and do it for the younger
Mhm.
kids. But I think that could be really some opportunities, kind of like peer mentoring that could be going on.
Caitlin, do you have anything to add there?
I was going to add on the peers, and if you are having students who are older, having them be that mentor for the younger kids or giving students specific jobs. So, for example, like if you know you have an older student, that student can be the reader of the group where they're reading to everyone, and which makes it more accessible for students because I'm sure like you're unsure of where they're reading at and what their abilities are. So having the older students take that on could be a great strategy.
Nice.
And like again, too, like with Scribe, you can have a writer during the planning process as well. So giving jobs is a way to make it more accessible for all.
Mm-hmm. And that kind of got me to thinking, I know, Caitlin, you're an inclusion specialist, and
Mhm.
my kids go to a school where that's just getting started. They're kind of transitioning to inclusion. And so if you're an educator, let's say, and you used to be a gen ed teacher, and now you're going to be working with maybe next year or it's happening right now, that idea of like integrating students and kind of transitioning to an inclusion space. Any tips in terms of like how can I get them used to STEM? How can I get everybody used to STEM? How can I just sort of make that transition from either Bree or Caitlin?
I think what's worked best for me is building a strong relationship with my co-teachers. The co-teachers have given me a lot of they trust in me and they have given me this opportunity to kind of take over and implement yes and make it happen. And so, but they wouldn't have done that without a strong relationship. So giving your co-teachers that time to kind of trust in you and trust that you're there for your students and that you're trying to give them new opportunities, I think is definitely like step one. If you are the gen ed teacher, then being open to trying new things with the support of the special ed teacher and knowing that everything, and I'm sure you all know this already, everything is trial and error. Just
Mhm.
try it. see what happens and learn from it. And then, like Bree was saying as well, you can always pivot, you can always change something. I think that's a really cool thing about educators is we get to try things and then we reflect and we can go back to our kids and be like, ooh, that didn't work out so well. And so just trying with your kids and trying with your co-teachers.
And then Bree, Kaitlin mentioned, she kind of goes when she's approaching a yes unit, she kind of goes to the PowerPoint. Is there like a starting point for these resources that you tend to gravitate towards, or is it some of the other resources that you use?
I think we definitely go to the PowerPoint, but we do open up the lesson plans next to the PowerPoint because I think we've seen that I think for people who are really new, um, sometimes they over depend on the PowerPoint and they miss the gist of what was supposed to happen in the lesson. Um, and so for us, we do that first. And then one of the things we do think about is um, we kind of look through and prioritize the like design process. And then what other content, like conceptually, would kids really need to know, or they're just like gluing stuff together? So
Mhm.
in the pollinator one, there's a lot in there. And I mean, there's a really cool lesson that talks about all kinds of different flowers and all kinds of different insects and how at night and open and close and the length of their beaks and all the things. Like we did it, but that was not a priority in the learning because we were going to talk about bees. And if like we had students who didn't know the difference between a butterfly and a bee, and we could have spent a long time on that. And so by us going through the lessons and really looking at like the unit and what is the gist, what are the big ideas that they're trying to get to, that was really helpful for us then to go back and prioritize. Not that we're not going to teach it, but that might be an activity of something we do, but not necessarily something that is we're going to spend 50 minutes on. If I can get a kid to sit down for 20 minutes, that's great. So that's going to be more of an activity that will not, I don't want to put a ceiling on what my kids are exposed to and what they're going to have opportunities to learn, but it's not going to be one of those things that I really need to make sure my kids understand before we start to design these things that bees move this pollen. That's like the big idea. And I've got to make sure. So that prioritizing kind of the learning and the experiences throughout the unit has helped us not over focus on things that kind of don't 100% matter to engineer.
Yeah, no, that's really helpful. I kind of want your notes as I even just what is the most important thing? Because I can imagine too, you facilitate it and you teach it, and then the next time you're like, you know what? What I thought was maybe the most important.
Yeah, or nobody understood it, but it didn't really matter because we moved on to the next lesson and they were cool without it.
Right,
And
right.
so I don't want to like, I never want to hold them back. And I realize that for me, I love it because I don't have to be the science and engineering expert. I get to be the special educator in this situation. And so I think that there is a side of being able to utilize the curriculum to determine where are the supports that help fulfill something that maybe is not a gap, that's not the right word, but like where are our strengths and then how do we kind of bring it in? And for me, it's been really helpful to not have to sit down and like research forever about how pollen and all the things that might happen to then create a pollinator, which the engineering is the big part I really want them to get out of this.
Yeah, yeah. Thanks. Well, I'm going to share a couple of other just links and things and resources. Please do, if you want to raise your hand, I can certainly unmute you. You can ask a question. Feel free to type anything into the chat. We have like another 5 minutes with our experts here tonight. So you can also share your thanks in the chat. Um, I wanted to just share, we heard a lot about all these amazing resources and how they were adapted from our curriculum. So please do, if you haven't already, go check it out. You can reach out to us. We're happy to help you, just kind of guide you towards resources that you might be looking for, support you with professional learning needs. Our newsletter is kind of a great place to go to learn about all the new resources we're coming up with because we've always got something cooking here. We just have some new career modules coming out and computer science resources. So a lot of great resources to explore. Um, and next month we do hold monthly webinars. So this is our February webinar, and our March webinar is all starting to think about summer school because it is February, but feels hopefully like it's around the corner. It does feel like I want it sooner than it's probably coming. But we want to think about integrating STEM learning into your summer programs, your after-school programs, so we can we'll focus a little bit more on some of our enrichment units and how some folks have shaped their summer programs around the YES curriculum. So you can register there, use that QR code, but it's also on our website. So that is all I have for tonight. Feel free to answer any or ask any questions. And I don't know if Kaitlin or Bree, you just want to thank you so much for joining us here tonight. And it was such a pleasure to hear from your expertise and to learn from you. And yeah, I appreciate
Thank
your
you.
work. Yeah.
Thanks for the opportunity. And I just want to, I guess, just kind of leave with um, encouraging everyone to just continue to extend our opportunities for students with diverse learning needs, and continue to hold them to high expectations and hold ourselves to just trying the next thing. That's
Yeah.
the best we can do, and just try and then recognize what worked and what didn't and keep trying.
Yeah.
So thanks.
Thank you so much, Bree.
Bree said it all.
Yeah,
I can't top that, y'all.
yeah, that's a great.
Thanks.
A great way to wrap up. Thank you so
Yeah.
much, Bree. Thank you, Kaitlin. I appreciate you joining us tonight, and thanks everybody for joining us. I will share the recording with you all, and feel free to hang around. I'll answer any additional questions. But have a great night. We can end here.